Once we've understood perfect competition, we're in a position to look at monopoly and how price and output are set by the monopolistic firm. And that's what this set of questions is all about. So let's look at the first question, where we have a number of statements to work out whether they're true or false. Statement 1, the monopolist has no control over the price of the product. Now that's clearly false. He does have some control. It's not like a perfectly competitive firm that has to take the market price. The monopolist is a price maker. The monopolist can use its power to choose any output and any price it likes. False. It can't do whatever it likes because it's constrained by the demand curve. It will have to pick a combination of price and output that lies somewhere along the demand curve. C. You can choose price or output, but not both. That's true. You can choose a high price, but if it does that, we'll sell a reasonably small amount. Or a low price and sell a larger amount. Any combination along the demand curve is possible. D. We'll make a profit in the short run, but only a normal profit in the long run. That's false. In the long run, because he's protected from new entries by high entry barriers, he's likely to make a profit above the normal, even in the long run.
Let's have a look at how a monopolist would look like on a diagram. First of all, we are going to mark the axis. So here we have output, and here we have price, cost, and revenue. How do we know the price and output that maximize profit? Well, the rule is the same. It is where marginal cost equals marginal revenue. So this is the profit maximizing level of output, QPM, and we read off the price of the demand curve, which is PPM here. So this is the profit maximizing price, and this is the profit maximizing quantity of output. Now, is that different from the price and output that maximize revenue? Answer, yes, it is different. The revenue maximizing level of output is where marginal revenue is 0, so it is here. And we can find out what the revenue maximizing price is as well. So this is QRM, and this is PRM. The revenue maximizing price and output. What is the price and what is the output that maximize social welfare? Is it the same as the profit maximizing or the revenue maximizing level of output and price? Answer, no, it's different. The social welfare is maximized where marginal cost equals demand. So this is the social welfare maximizing level of output, and this is the price. Well, we can clearly see it. It's the marked triangle here, and it is the difference between the social welfare maximizing level of output and the profit maximizing level of output for a monopolist. So, is it possible for a monopolist not to make any profit above normal in the long run? Answer, yes. If demand falls, if the demand curve shifts to the left so far that it can only cover costs, the monopolist will not make any profits above normal in the long run.
Now what we're going to do is to try a quite difficult task of working out what happens if the government introduces some control over this monopolist, particularly if they try to introduce a price ceiling to prevent the firm from charging a price above the social optimum. Needs to be thought out quite carefully. Let's look at the diagram though and see if we can do it. The social optimum level of output, as we saw just now, is at QSO, and the socially optimum price is at PSO. So let's suppose now that the government imposes a price ceiling at PSO. Let's work through what that's going to do to the firm's price output decision. First of all, how does the price ceiling change the effective demand curve? The firm is no longer in a position to charge a high price for small levels of output. The demand curve becomes from PSO across to Z. If it makes an output less than QSO, it can't charge more than the PSO price. So the price ceiling becomes the effective demand curve up to output level Z. That means we can now work out what the effective marginal revenue curve is. We've turned this firm as a government into one which is like a perfectly competitive firm. If it adds more to output, it doesn't need to reduce the price to sell more. So the price ceiling is also the marginal revenue curve. So finally, we're asked, where does marginal cost equal marginal revenue? That's what the firm will always pick as its level of output. Now, marginal cost equals marginal revenue at QSO. So the price ceiling is effective if it's set at the socially optimum level of output. It persuades the firm to make more output at a lower price. We said earlier that price ceilings are bad, and they are if it's a competitive market. But if you have a price ceiling in a monopolistic market and the price ceiling is set at the social optimum, the price ceiling can successfully persuade the firm to make more output at a lower price and bring it in line with the socially optimal price output decision. Now finally, we turn to something that we didn't study in the lecture, and that is the mechanism for controlling monopoly power which is used in the United States of America, and that is the Herfindahl Index. But you should have seen the Herfindahl Index at use in the film that I asked you to watch. So now what we're going to do is to look at the use of the Herfindahl Index as a means of controlling monopoly power. The Herfindahl Index enables us to see how much monopoly power there is in any particular industry. Let's look at the formula. It's quite a simple one. The Herfindahl Index H is given as the sum of the square of the market shares of the firm. We take the market share of each individual firm, square that, and then add them together. And that gives us our Herfindahl Index. And we'll now look at a couple of examples of the Herfindahl Index in practice.
What is the Herfindahl Index for an industry where there are 4 firms, each having a market share of 25%? That's pretty straightforward. Let's have a look. So we have an industry with 4 firms, each having a share of 25%. What we need to do is to square the market share of each firm in the industry. So we get 25 squared plus 25 squared 4 times. And in the end, we get the result of 2,500, and that's the Herfindahl Index for an industry with 4 firms, each having a market share of 25%.
Now let's imagine that we allow mergers to take place, and we finish up with 2 firms, each with 50% of the market. Will the Herfindahl Index give us a higher number, show us that we have a more concentrated market structure? Indeed it does. Let's have a look at the numbers. So we now just have two firms. Each one has got 50% of the market. So again, we square the market shares of these two firms, 50 squared plus 50 squared, which is equal to 2,500 plus 2,500, which gives us a value of 5,000. The Herfindahl index lies somewhere between 0, which you would have for a perfectly competitive industry. Each firm is infinitely small as a share of the market, and 10,000, which you would have for a monopolist, which has 100% of the market. And the competition authorities in the States use the Herfindahl index to decide whether to allow a merger to take place or not. So we now have an understanding of perfect competition. We have an understanding of what happens when a firm is a monopolist. We'll now be in a position to look at some other market structures which will give us further insights into the way in which prices are set in a market economy.